Hello, everyone. I hope you had enough time to fresh up. So my talk will be about how you can split your features in an independent way by using the Dagger components. I say features because I want to refer to the instant app terminology rather than the Gradle modules, because it kind of helps in this subject, because then Dagger has a module and then Gradle has a module. It's kind of confusing. My name is Yahya Bayramoglu. I'm working as an Android developer at Booking.com. I want to start with some questions because the subject is highly dependent on Dagger. So who is already used Dagger Android here? Great. How about Dagger 2? Just Dagger itself, not Android. OK. And who have struggle or, let's say, deal with custom scopes? OK, good. And who has a huge application component with build in an application scope and has a lot of modules on top that depends everything there? Good. That means everyone else is using Dagger Android, I assume. Cool. So how about if your app is already big enough that you were working with Dagger and then Dagger Android came out and then you were not able to migrate, right? I would like to also ask one more question. Who has deal with instant app? 1, 2, good. Why do I ask about instant app? Because I want to give some basic information, and depending on the requirement from instant app, that I will explain more details how you can and you need to split your dependencies. So instant app runs single feature almost instantly. So when you open from Chrome and click on a link, and if it supports instant app, you just see a very short loading, and then it launches the instant app. But it has a certain requirements. So you need to fit in the 4 megabyte. You need to have a deep link accessibility, and features cannot depend on other features. This is the most important part. I mean, this is for modularization, I think, in general, most important. But instant app by itself, very good sell point for the business. So if you want to go deeper in modularization in your app, please look into instant app and use as an argument in your business support. So if you would look into instant app, that you would see some hierarchy like this, that the basic requirement is to have a base module, and then feature modules depending on that base module, and then your app module depends on all the features. But of course, you can have all the other feature required modules or separation of concerns, whatever you want to extract into separate module. The key point here is the features cannot depend on each other, and we want to keep it that way. This is in order to achieve instant app, and I would still say the best approach to have the modularization. But can we take it even one more step further? Can we build our application by just removing the rest and just run the feature one as a single application? Let's see. So in the end, what we want to do is, if this is our dependency, I just want to remove the implementation of feature 2, 3, and hit the run button, and I expect my application to run, which is not quite possible if you are using Dagger, because the dependencies are statically defined, right? So just removing the dependencies from Gradle will create, hey, I cannot find this class. OK, let's move on. So first of all, a basic information about Dagger 2. It's a dependency injection framework. It builds the graph in the compile time. Dagger 2 is not Dagger Android. Why do I say this? Because Dagger 2 is the core of the project, the framework. Dagger Android is an addition module. I'm not going to go details of scope, component, and module, but it is, I assume, known. So I'm going to talk about the application scope, though. Scope itself actually is just an identifier. The way that scope gets lifecycle aware is in which component you define it and where you keep the instance and when you release the instance. So if you do in the activity that you can call an activity scope, if you do it in application, you can call it an application scope, and you should respect to the release the component that you create with that scope within the lifecycle. So application scope. It's a single instance for a long of the application lifecycle. But why do we even need that, right? We have the singleton annotation. Let's see. First of all, we want to provide the application context. Every library, more or less, depends on an application context and needs to be initialized on the application. And we want to have the single instance to manage correctly. And as I mentioned, why do we need it? There's also a singleton annotation. But that doesn't, the application scope actually is not quite same with the singleton, because singleton, it has double check, and also it doesn't allow you to have more instances of that's called singleton, right? Application scope more or less provides the same functionality, because in Android world, application is the single entry point, right? So after that, you know that the instance you keep in the application will be single through the application. But if it was an application scope, let's compare with an activity scope, for example, you can define singleton once and you will have the same instance, but defining activity scope will not give you the same functionality. Just very fast going through with the scopes. What I want to talk about is this, basically. Considering that you don't use Dagger Android, and you want to provide some modules and objects throughout the whole application with a single instance, or you know that these objects can be used for the whole application lifecycle and so on. So what you need to do, you keep an instance of application component, and then you define your modules as a dependency on the component. So what the problems here, modules need to be defined statically. So if we refer to the Gradle dependency that I've shown, removing the feature 2 and feature 3, with here say, hey, then feature 2 module, I cannot find it, right? And different features need different dependencies. Of course, I don't know, depending on the feature that might require Firebase, the other one might require whatsoever dependencies. And of course, they are sure that needs to be available through the whole application lifecycle. And they are initialized even though user might not use it, right? So I might have an application with 5, 7 different features, and user just opened the application and just saw the first one and then didn't go through the others, but they are already there in the graph. And it makes them kind of explicitly dependent, so I have to declare and make sure that it is there and so on. So if we put it in a graph, it more or less looks like this, which please be aware that application scope means that it is tied to the application lifecycle, and the feature-specific scope can be any other scope that you define. And let's assume that you keep the application component in the app module, and then you provide a feature component, which depends on the application component, and it needs feature 1 module 3, which module 3 depends on the module 1, and module 2, which is supposed to be in the application component. If you can see that it's kind of creating a circular dependency, this is what we want to avoid. So if only we could provide something like this, saying dynamic model key, feature 1, feature key, not defining anything statically, and saying, hey, I want to just have injected whatever models that is having the same key. Appending models with the same key if exist, and decouples models dependencies because they are not a static dependency anymore. Of course, this needs to be supported by the framework, right? So what did I do is just go to the repo and ask for it. Well, as you can see, it's closed. Why? The reason was that it defeats almost all the benefits of Dagger 2, and Dagger 1 did it, so if you want, you can use that one, which I don't want to go back to the runtime dependency graph generation. And the alternatives, maybe you can use interface buildings and so on. But wait a second. In Dagger Android, we have this contributes Android injector, right? Which actually does collect dynamically the models, right? And there's no static model reference required, and it just works. Sure. Let's see how it works. This is from the Dagger core source code. And if you look at the name of the method, it says collect implicitly included modules. Nothing related to Dagger Android, but if you look at closer, you see that hard-coded package name from Dagger Android module is injected into modules. Okay, so this means I cannot use the way that Dagger Android is built because it's not scalable, it is hard-coded, and it makes core module aware of the additional module. Okay, so I cannot have the collective modules. I cannot gather modules from the features to the upper level, right? So to add to, if you remember the graph, like app, feature 1, feature 2, feature 3. And I cannot move my modules to the upper level. I can, but I don't want to. So can I somehow push the application component to every feature then? Did anyone tell us that application component should be only one? No. Let's see. How do I want to implement it? So I want to have still one application component so that I can still reuse the instances throughout the application. I want to still be able to provide one instance throughout every module and application, right? And I want to have features, their own application components as well, so that they can provide their modules, their instances that will survive through the application lifecycle without going back to the application component, application module. And I want to generate these components only when they are actually needed. So if user doesn't go to that section, they should not be in the graph. And application just needs to work as a proxy so that it can distribute the components. And of course, doing that by not being aware of any feature so that I can just remove from the dependency Gradle and then still expect it to work. Okay, how do I do it? I need some isolations, which always start with, before going there, I want to also explain this with another graph. So at the end, if you remember the previous graph, it was a bit more different. At the end, what I want to end up with this. So having an application component which feeds every feature with itself to create their application component. And from that point on, everything is more or less same, but without actually pushing the modules up to the application module. And there's no circular dependency, so there's nothing going back to the application, and you just have a vertical differentiation. So, of course, I need an isolation to do that, and it always starts with interfaces. So I will point out the base part, if you remember the graph, base, feature 1, feature 2, feature 3, and application. So I will point out the modules here to make it easier to follow up. Okay, interfaces. I have three interfaces. Application component, core application component, and feature application component. Core application component, the one that I can provide throughout the whole application. Feature application component is the application component for the feature. Okay, I have a core scope, application scope, just not to mix it. I created a separate scope. Why not? So sample core component extends core application component interface and have the module that I want to provide the instances. And this is in the base. So it is provided through a whole application. And of course, I need an abstract class extending the application. I create my core application component already here using the Kotlins by Lazy. And of course, an abstract methods that I return feature 1, application component, feature 2, whatever. So you already see it's not scalable, right? Good. And of course, I add the interface here so that I don't know who is going to implement and what I need to return. It's still in the base. And so by doing this, what we achieved is I already have one core application component that I can reuse the instances. Okay, let's move on. The next one is I have feature 1 here. And what I'm going to do is to create a feature application component, whatever I need. And then I have the component dependency, which is core application component, so that I can reuse everything from that component. You can also do with the subcomponent. I rather not personally make the dependencies explicit. So, so I have the feature 1 component, and I have the create method so that I can build it later on. And you can, of course, by using Kotlin's magic, have an internal function that means is only visible for the module, which, assuming the feature 1 is a separate model, that you can have get application component extension function that returns the feature 1 component, and you can have the same method with all the features returning different components, and you can have actually the consistent way of retrieving the component application. Okay, by doing that, I managed to have the features have an own application components. Let's see how am I going to do the lazy part. This is the app, so this is the highest hierarchy we have. And I extend the base sample application, which had the core component generation part. And I override the method called feature 1 application component, and I return the feature 1 component, which is created by Lazy. So the moment I call this method, it will generate the graph and then return it, the component and return it. Okay, of course, this goes for all the components that is required. By doing this, then I get the generating component only when it's needed. So if user never goes to feature 2, no one calls get feature 2 component, and that's never generated. Okay. And I kind of managed to get application working as a proxy. So every feature component, application components, and the core application components is in the application, so it's just distributing through the features. But as you can see, there is a feature 1 component here which creates an import that kind of still makes the application is aware of the feature. So far is good. I mean, if you come until this part, I think you're already good to go. You have only a single point of dependency, so you don't need to actually be worried about features exposing the model, but they just expose one component, so you just remove from one point. Because if you expose modules, it is a bit more wider than the component, so that anyone can be introduced into as another dependency using it. But I want to also solve that problem, which is not possible because of the reasons that I explained how Dagger is not supporting it. Okay, then, so this is a proof of concept that if we want, we can find a way. It is not a production ready, so just to give an idea how we can achieve what we want to, but it still requires some more work to be working, basically. ComponentDispatcher is a library that I've worked on to be able to achieve the last point. And I'm just going to go very fast, detailed explanation. So I needed something that will collect all the information at some point so that I can build my dependencies without actually defining them in a static way. So the only thing that I know that it is eventually merged is manifest, right? So if you have different features in the different modules, and if all of them has their Android manifest, we have a Gradle task that goes and collects them and merge them, right? So what do I do is basically just use the metadata. I printed the generator sources, and I define also the core source. And so just to a very fast explanation is the core components generators is a list of strings to be used as the keys for features, and the component generator core is the path of the component generator. And the way that I define is always to get the key and then define the path. So it's like a key value definition. Okay, so let's go the component generator. It's a sealed class because I want to have core and feature generators separately, and they have different requirements, of course. And it has the application in sense of more or less every application component needs an application to initialize whatsoever. You don't have to use it, but you can still have it. And it has the component that as a generic type, whatever you give. But what is this component class here is to be able to map the type with the generator so that I can get the component whatever type that is required. It's just a sugar. I will explain later on. So I have two generators. One is core component generator. The other one is feature component generator. They are sealed class. They are extended from sealed classes, so I know that I will have only these two. And then I have the component generation by lazy, so that whoever extends this, they don't need to care about it. And then I have the generate functions that should do the work, basically. In the feature component, I also have the core application component, so to be able to inject into feature application components. I know it's confusing, just bear with me. And then there is this ComponentDispatcher, which we perform some black magic ritual. What do? I just read the metadata. I parse the component generator locations. I create a map with all the generators, type as a key and the component generator as a value. The magic is here. It uses reflection to initiate the component generator. But assuming the 5, 6, 7 features, it should be OK. But still, as I said, this is not a production ready. This is a proof of concept. So I'm in the base. What do is just to have a core component generator saying that I'm going to return a sample core component, overriding the generate, and then return the instance of the component. The same goes with the feature component generator. I have both application and core application component, and I generate and return the feature one component. And I'm still in the base. This is important. This is just to showcase that I don't even need to do this change in the application because I don't provide anything to the upper layer. What do I do is get a component dispatcher, create the instance on the onCreate, and just simple gather method. Well, and of course, since I don't specify anything, I can also say, hey, any activity can have the component dispatcher value, right? So by doing this, if you notice, there is nothing related to feature here, right? So I'm actually also managed to make the application not aware of any features. And the usage would be in any activity. You just call component dispatcher, get, and you give the type, which is used to identify by reified, and then it returns you to the feature one component, and then you just call it inject. So if you are using Dagger Android, you don't need to go through these things. But if you're not using Dagger Android and you want to have something similar to Dagger Android, this might be a way. It can be done most probably with annotation processing or the Gradle plugin. I didn't go more details since the build time issues about Dagger and so on. You can find all the information about how the first implementation was until the component dispatcher with the interfaces and so on. You can find the component dispatcher here, and you can find the blog post about all the stuff that I talked about it. I'm going to share the slides later on, so you can also find it on my Twitter account. It's exactly this. Yeah, that's more or less it. Thank you.